So, hello and welcome to the Road to Las Vegas 2024 case. Almost there. This is my second attempt recording this video because the first attempt was stopped after I pressed the wrong button, and then I talked for 22 minutes without noticing. So, this was the first case by Emil Saulitis. I hope I pronounced that right. And as you may know or may not know, when there are first cases, then there is a tendency to do map cases, and we also have here a map. So we have both a map case and a few 4 levels are like data analysis cases. So like here, nothing too spectacular, although nobody scored full points. So yeah, I did not so bad in this round, but also not good. I will later show you a few problems that occurred while I was solving this. So also a little bit, I will do bonus 1 and 2 first and then start into the game. So which country has been represented the most time across the data set? And as you will know, this is like a real data set from the rounds, and therefore you will know probably that the United States are the most common country there, but we can also use here the group by function to determine this. So group by after country, and also our values are our country values. We want to count them, but count A. And sorting -2. And then you get like United States as the result. And with the add operator, you can have everything in a single cell without spilling. And so far solved. So for the next thing, we need to go back to the map. And there we can apply a count if select the whole table, but be aware that you scroll down enough, and then criteria are given here, and then you see, so like cactus or cacti, it's like the plural, and rattlesnakes are in sum 26. Bonus 2 also solved. So here for level 1, how many points did the winner score? And therefore we will use like xlookup. So we search after the battle, and then after the highest possible score, so 1250. Lookup array will be then the battle column and the points column. Return array will be the points, and our match mode will be -1. So exact match or next smaller item. This will give us the result, and we can track this easily down because we have selected the whole column. The next one are points per minute. So we need to do something there, and therefore I will first determine the time. So I did the dim approach and did a pre-programmed lambda to determine the time. Because you will see in the introduction video that the time is formatted with this approach. So like a number, then an M, double point, a second 2-digit number, and then an S. So I made a pre-programmed lambda before starting the 30-minute timer. And yeah, this lambda worked, but I later stumbled over a problem, so I will use here not my pre-programmed lambda. So our 0 minutes are left, and here 2, and you don't need to make this here a number. The time function will also work with like here text as numbers as text. And then the 30 seconds we use mid. Starting number is the 5th position and 2 characters long, and we have our time in an appropriate format. We can now use that. And now points per minute, PTM, is like points divided by time. And you get here a large number, and then you need to divide it by 24 and by 60 to get this in the points per minute format. Now we want to determine this for the participant and battle combination. Therefore, we look up for both participant and battle, and return will be points per minute. This will lead to an error because we need to round. Never forget rounding. Or please FMWC make the rounding standard in like the codes down below. And you don't need to input here something. So like the default for number of digits is like 0 if you leave this out, because nothing is a 0. So you need to input there the semicolon or the comma, but not a number. Which person was ranked right after the given participant in specific battle? Don't forget about tiebreaker. So in the introduction video, and I think I also in the live attempt only used like the explanation from the introduction video, you learn that there is a decent sorting. So like here, custom sorting. First, we sort after the battle. Then we sort after the points, but decreasing. Then we sort after the time, but now the time we have created, and they're like being shorter is better. And then after the names, because there's the possibility that there are guys with the same points and the same time in the same battle, and then it's like alphabetically done. So now we've sorted everything, and what we now do is use an X match after the participant and the battle in the participant and battle column. Yeah, and we get a position, and then we use an index over the name column and 1 plus our matched approach. Not F3, F4, 2. Jump there, close the bracket. You can also do this like X match and then +1, but yeah, never mind. So far 3 levels solved. Yeah, nothing too spectacular there. So here, average time spent solving the case, and there I messed a little bit up, messed things a little bit up, but here you will see where. So we filter first, everything, or like the time, because we only need the time after the battle. So to get like here the right battle, and then we have like a filtered build range or dynamic array. So name this F, and then we want to have like a rank so far, because it's as it is sorted, we have a rank here. So sequence rows of F, and name this S. Then let's see. So we have here our ranks, and what we now want to do is have a second filter our filtered array. If this is even, then we want to filter after is even from S. Otherwise, we want to have is odd from S. Close all the brackets, and we get here only the even times for battle 5. We can then apply an average, and we have here a time. This time it's like formatted as this number code Excel does. And what I thought I can use here is like text, and my format code will be then hashtag m double point hashtag s, close the brackets, and you see I get an error because I'm not so familiar with error codes. I tried it around 5 minutes and then did a manual approach in like dragging this here down and then typing in here 29 s 29m double point 12s. I think I did not make a mistake there with like this manual approach, but it was like slow, and so I later stumbled over another approach. So you can use the minute function, then an m double point, and then the second function, and then an s. Yeah, wrong bracket. Yes, yeah. And there you get like your things, but you will see there's a problem. because here I don't have the leading zeros for the seconds. You don't need this. Is this the right error code? Is this the right code? I don't know. No, hashtag is right, or no. You see, I'm not so familiar with format codes. 00, I guess. Yeah, worked. And as no one has scored like under 10, or not in the average, under 10 minutes, you don't only need to apply this for the seconds. So level 4 solved, and now it's getting a little bit more tricky because now we are coming to the map kind of thing. Or we can do bonus 2, bonus 4 there before. So here you need to take attention because we need to have the overall points per minute. I made a mistake and calculated the average overall point and not the average point and not the overall points, because for the overall points you need two group by functions after the name, and you then want to have the points and they're an average, and don't want to sort this. And then you also want to have their values, not points. Values now should be the time, select your correct time, and then you want to calculate the overall average points after the divided by the overall average time, and then you want to have like an XLOOKUP after the large values of this, and you want your seventh largest lookup here and return the name from here. Yes, I guess. Yeah. And your answer is Bo, the Excel wizard. And yeah, it's right. So I made a mistake. I didn't calculate the overall points. I calculated the like normal average and not the overall average. Silly mistake. So far so good. And also here I made another mistake, and I will show you what. First of all, let's go to the map. I first want to have all the position of cases. Therefore, I first copy here the map. I think I've copied not from below. Yeah. So name this M. I can delete this. I don't need this. But I also want to have like the formatting, just to have it a little bit more visualized. Only the formatting. Yeah. And now make this a little bit smaller. And what I now want to do is like find and replace. After this format, replace with a 1. 10 replacements because of 10 cases. Then I want to have this whole case, this whole thing as a single column. Also erase this here. Then I want to have the addresses, address of range. Yeah. And now I want to filter the addresses if the value is 1, and I get the values of the cases, but pay attention to this unsorted currently. And what I did then is like using this here, transpose this, paste special, transpose values. There's also a shortcut, but I don't know this. And then I also need to make this here everything once. 272 replacements because I will use the maze solver move path lambda. Yeah, it is getting slow. So my start address is like the address here, and the target address is given here. Diagonal cutting is not allowed. No, not allowed in this case. Fix this, and we can then track the serial side. Here, calculating problems. Control S, yeah. And now what I did, also a mistake. I used here the standard min function. Track this aside and thought, oh, super easy, I can put this here in. But as you will see, there are a few errors. Transpose values. Here, there are a few errors because you need to go to the next battle case. And next doesn't mean next in like next position wise, but next in like time wise. And therefore, I will also implement here a second. What is this? Yeah, don't need this. Implement here a second thing. So it's because I have also the maze solver distance map. This is like my maze. Start address will be. Oh, sorry. Things are messy tonight. Start address is B2. Close the brackets, and you now see I have here this like maze and like increasing order, and then I make here to call to make this into a single column, and then I can do here an XLOOKUP after those values here, inside here, returning this, and I now have the like position there are, and now I can determine here I have the position there the cases or case cells are in, and I can now determine. Sorry, let me think for a second. And then yeah, I used here filter function, so like only filter this values. Oh, sorry. Yeah, too late, guys. I filtered did also an XLOOKUP on those positions here, and then I used a filter function to filter those values here if these values, fix them, are larger than this value here, because then I know, oh yeah, this is a thing that will follow, and then I can use here based on this things here the min function, check this aside, copy this in, paste special, transpose values, and you see everything solved. So far 5 levels solved, and I can now also say I will not do bonus 5 here. There's also like a small discussion in like the in the community about what is the answer for bonus 5. So here I've not I made I tried something on bonus 5 with like a kind of a manual approach, also using, I can show it to you. Where is it? So yeah. No, sorry, this is the wrong one. Sorry for that. Yeah, I know. Escape. This is do. Ah, yeah. Now this should open. Yeah. So I did here a kind of a, where is it? Oh no, it's not YouTube solved. Sorry for the mess and for the sound. So I did a kind of a manual approach using like my make solver, where I said, oh, I start from there and go every time to the smallest distance, but this will not lead to a result. So bonus 5 isn't for me here, but we can do bonus 3 there shortly. Because we have here our distances, we then need to sort this, sort by, sort this after this here, or what you can also sort this after this, and then we can also sort this here and do like this minus drop of this, drop the one, and then here ABS, and you see here your maximum is multiple times 35, and 35 is also the maximum number of days between levels. Then back to level 6 and 7. So level 6, I have a lambda. It's called returns areas based on indirect cell reference. It's a super basic lambda, or it was a super basic lambda. It was like an indirect mixed with an offset. But then Dim said to me, oh, will it handle borders? So it will handle borders until now because of Dim. So if I'm like here in A1, for example, and then it says, oh, like go 10 to the 10, make a 10 by 10 array around it, it would have faced an error because I crossed the border here out of the spreadsheet. But now it will not cross borders, but I made the mistake that I that the size of the array wasn't adjusted when I hit a border. So I did not step out, but I also here the array was like the same size, but I've corrected this, and I can therefore use this lambda super easily. Returns area based on indirect cell reference. Need the cell reference. Range is 10. Sheet name is M. And then I only want to count if for like this here. It's like a 3. And you see with a pre-programmed lambda, this can be solved in seconds. I have here an error. Yeah. And I don't know why, because as there are some cactus and stuff here, this will this will not face like or recognize. Oh, that was too much. Recognize the borders here, so it will go out there and then recognize that there are cactus here. But as of now, this is solved. So last level, because we have solved the bonuses. Sorry for the mix-up today, but yeah, and bonus 5 isn't on my page. I'm looking forward for Dim's video on this. And this is also kind of a easy level if you know how to do this. So I copy the map a second time. L7. Here. Then here. I make this smaller. I know that I can step over walls, so I make there a red X. And I also know that around snakes I can step also. So here 3 by 3 square. And also need to pay attention, there is a different formatting for this. And I now manually paste this everywhere where snake is in the direction, so that the snake is in the middle. Yeah, this is kind of a manual approach, but you will later see that this is kind of a fast approach if you have those lambdas. So every snake is like pasted over, then I use Control H, replace After this, replace all. This will take some time. And it was important that we also had here this like in red, because otherwise it would also be overwritten and then manually. You can do this also like for the cacti, and for the pawn trees it's like also you can do here this non-manually, but for the unlike battles I think it will be good, or the fastest way to do this manually. You see, it's also not interesting to watch, but you can then check if there are any errors, because for example here there is like a different formatting applied, and then this was blank. I think the case design team did something there, and we are ready. So, and I now copy only this into the sheet to not make a mess there with like my lambdas, and I now use easily the maze lambda on this. My start address is given here, target address is also given here, and diagonals cutting is allowed. Drag this down. Oh, sorry. Fix also georeferencing, and yeah. And then drag this down. Little calculation running there. Copy this in, and then also level 7 is solved. So far 1170 points, and I'm looking forward for bonus 5. So thank you for your attention. I hope to see you also with the next videos. I didn't qualify for the Microsoft Excel World Championship main draw so far, but you will never know what the other rounds will bring. And I'm also with the MEWC in Las Vegas, so hope to see you there. Thank you for your attention. See you next time. Bye.